Hey guys, what's up everyone? Welcome back to another video tutorial from the AP3X Institute of Mathematics Education. This channel primarily focuses on contents related to the CSEC, CCSLC, SEA exam curriculum. Alright, and in today's tutorial, which is part 1 of 3 parts, we're going to be covering extensively the topic of coordinate geometry. We're going to be going through every single details as it relates to this particular topic here with a fine-tooth comb, and we're going to ensure that you get a variety of basic, intermediate, and advanced examples that will give you a complete guide. And of course, regardless of whatever type of questions that may present itself on an exam paper, with this tutorial you will be able to master this topic. All right, now for future tutorials that are coming out as it relates to the CSEC topics, you can definitely get access to a few of those on the channel by smashing the subscribe button below, turning on the post notification bell. All right, if you get some value from the content, leave me a like, and of course leave your questions, comments, suggestions down into the comment section below. All right, so we're gonna get right into the video without further ado, and then we're gonna learn a lot about this topic called coordinate geometry. Let's go. All right guys, so starting off with a very basic definition here, that coordinate geometry is basically a branch on the mathematics tree that primarily focuses on everything that is related to a straight line. Right, we focus primarily on everything that has to do with a straight line. Now as it relates to the topic, there's a bunch of sub topics that really comes with this, and first thing that we're actually going to be looking at is, in fact, how to draw a straight line on a grid, how to find the gradient of a line, how to find the length of a line, the midpoint of a line, how to find the equation of a line given a pair of points, given a point, given the intercept, given the gradient, how to find the x and y intercepts, how to determine the coordinates of a point, finding the equation of a parallel line and a perpendicular line or bisector. So all this plus more is coming up in this complete tutorial video in 3 parts. So we're going to be going for about an hour here. All right, for about an hour. And so tune in guys, and let's get right into our topics here. All right, now we're going to start off pretty much by understanding a very fundamental concept here that relates to what is a point. All right, what is a point? What exactly are we math teachers talking about when it comes to a point? So a point basically is a location or a starting point of a shape or an object that is drawn in open space, or it's drawn on a plane or on a grid. All right, that's basically what a point is. All right, it's a location. A point, well, that is supposed to be represented, guys. A point is represented by a pair of ordered values. All right, and we call these ordered values, we refer to them as coordinates. All right, and usually they are written in the form x comma y. That's typically how we would write our point here, x comma y. All right, so the first number given a point is always representing your x coordinate or your x ordinate, and the second value here always refer to your y ordinate. All right, and together they are called coordinates. Okay, now basically when you're given this point here, right, this location here, it pretty much determines the exact location of the point on a grid or on a plane. All right, very important that a point has no dimensions such as length, width, height, or thickness. So pretty much we use like a full stop like this, and we usually label it with a capital letter P, A, B, C, as you see here on screen. All right, that is how we typically label a point. Now, once we have a clear understanding of what is a point, then we can now therefore look at what is a line. Now, a line is basically a series of points that are connected by a straight path. That's the definition, or the simplest definition for what is a line, right? It's basically like a bunch of points that are on a grid, but they are connected in a straight path. All right, points can also be connected on a curve, which of course you would know that that is called a circle. We're not talking about the circle now, we're just going to be focusing on the line itself. Now, a line can easily be drawn by connecting any 2 points. Now, even though we know that a line is a series of points, you don't need a series of points to draw a line. All you need is any 2 lines that are in a straight path, and that is how we get a line. So here's an example. Here we have a line that is traveling infinitely in both directions, and here we have point A and we have point B, and once you're able to connect A and B and extend in both direction, you will find yourself getting a line. All right, so far 2 very important concepts as we move on to the next phase of coordinate geometry. Now, earlier I had mentioned something to you about what is a plane or a grid. And so basically in coordinate geometry, we refer to the plane or the grid as being the Cartesian plane. All right. And a good representation of the Cartesian plane is actually a graph paper. A graph paper is what we use to draw our Cartesian plane on. Now, it would be good for you that as you're watching this tutorial, you have your own graph papers and you're following along as I demonstrate. All right, don't just watch the video, work along with the video. Pause the video, attempt some of the problem questions, then replay the video to see if my solution matches yours. All right, now what is the Cartesian plane? The Cartesian plane is a grid / a graph that helps us to identify the exact location of a point. All right, now basically it forms a relationship between 2 specific variables, and these 2 specific variables are an x variable and a y variable. All right, so the plane is formed basically by a vertical and a horizontal axis intersecting each other basically. All right, so we have the vertical axis here, and you're gonna learn down here that it's called the y-axis, and we have the horizontal axis here, which is called the x-axis. And usually we just kind of use like a 1-to-1 scale. The scale can be changed depending on the nature of the question, but for the most part we usually label our axis using a 1-to-1 scale. What does 1-to-1 scale mean? It means that for every 1 unit or every 1 stroke here, it represents a unit of 1 along the axis. So as you can see, if I'm to zoom up here, you will see that here is 1, this is 2, this is 3, this is 4, and here you can see I've already labeled 5 for you, not to just make it a bit clustered, but I've just labeled the obvious point 5 and 10, -5 and -10. All right, now it says here that the horizontal axis, that's the one that is lying down this way here. The horizontal axis is known as your x-axis, and the vertical axis is called your y-axis. Now in the future, you're going to hear other math teachers, other YouTube channels, or even myself may refer to the x-axis as being what is known as the codomain, and as well as, sorry, pardon me, I'm going to refer to the x-axis as being the domain and refer to the y-axis as being the codomain, or sometimes referred to as the range. But that's for a later tutorial. We're going to elaborate more on that. All right, now the point at which the x and the y-axis intersects is known as your origin. So right here is what we refer to as being our origin. Okay, so here we go, just a second here, guys. So right at this point here, we're going to refer to this as being our origin here. All right, just a second here, guys. All right, here we go. So here, this is called our origin, guys. Okay. All right, and so the coordinates of the origin, and this is something that you need to remember, guys, is that the coordinates of the origin is labeled as 0, 0. All right, 0 on your x and 0 on your y. Okay, all right, good. So we've gotten that clear. Now, the Cartesian coordinate system was in fact implemented by René Descartes from France, all right, which as before was used to find a specific location of a point. All right, so the Cartesian plane here, right, René Descartes actually invented this particular mathematical model. And so from back in the 18th century, this is what we have been using to determine the location of a point. All right, really brilliant invention here by René Descartes. All right, now a point is basically a point basically comes in a pair. And since there are two variables involved with you labeling or identifying a point, then basically you must plot on the Cartesian plane the x value first, whatever that value is. All right, it will tell you the direction, followed by the y value. Very, very important, guys. You understand that when you're plotting a point or you're reading the point from the graph, you're always reading or plotting the x ordinate first, followed by the y ordinate next. So you always travel along the x-axis, being your first movement, and after you've made that first movement, then wherever you stop, you're going to take an upwards or a downwards movement to plot your point. All right, now here, for example, we can read up the point A. If we were to look at this particular Cartesian plane here, and we are trying to find the location point for A, we would say, let's zoom up here for you guys. So A here, we'd have to travel from the center here, and we go 1, 2, 3, 4, 5, 6. So it basically stop at 6, all right? And then now you realize that we stop at 6 because we are right underneath the point A. So we then travel up now. That's 1, 2, 3, 4, 5, 6, 7, 8. So the coordinate value of the point A is in fact 6, positive 8. All right, beautiful. Now let's have a look at point B here. Again, we come from the center and we begin to count in the direction that takes us to B. So that's going to be 1, 2, 3, 4, 5, and again this is 6, but because we're traveling to the left of the Cartesian plane, that becomes -6, and then we're going to take a couple of steps up. That is 1, 2. We're right at B here. So basically the coordinate value of the point B here is -6, 2. All right, and finally now let's have a look at the point C. Back to the center again, and then we start to count. That's 1, 2, 3, 4, and then we're right above C now. So we take steps down. That's 1, 2, 3, 4. So we traveled in the right direction, which is +4, and we traveled in a downwards direction, that is -4. So the coordinate value of C here is 4, -4. All right, that is basically how you read off the point from the graph. All right, so as you can see here, it says usually the scale on the axis is a 1/1 unit. So depending on the objective of the question, you may have to change it depending on how large or small the values of the coordinates are. But for the most part, normally we just use a 1-to-1 scale. All right guys, so I hope that you guys are following so far and you've gotten your fundamentals down. Let's continue to progress through this very interesting concept here known as coordinate geometry. All right, so leave a like if you haven't done so as yet, guys. Let's jump right into another section here. Now, how to read the Cartesian plane. The right side and the left side, we have already demonstrated that by plotting our points, or reading off the points of the graph. But let's just get some theory behind what we have done. The right side, that is over here. All right, so the right side that's over here, Let me just take this out here, guys. All right, so here we go. I'm just saving the document here, guys. Pardon me. All right, so the side over here, all right, so the right side of the Cartesian plane and the left side of the Cartesian plane here, or of the origin, is your x-axis, this line here. So this is the positive side of the x-axis, and over here is the negative side of the x-axis, okay? And that's what it's saying right here. Positive and negative integers together are called x-coordinates. Now, above and below the y-axis, or I should say the origin, right? Above and below, here and down here, that's called your y-axis. Here and here, down here. So this is the origin. Above and below, you're going to find also positive and negative integers. So above, positive, below, negative. Very, very important that you understand how to draw your Cartesian plane properly. All right. Now, a simple way of, I mean, there's so many different ways that you can actually look at this, but a simple way for me personally of visualizing and understanding the Cartesian plane is to visualize the intersection of two number lines. All right. So basically, we're already familiar with what a number line is. All right. So if you take a horizontal number line and intersect it with a vertical number line, then you're going to basically have your Cartesian plane. All right, now prior to this we have already learned how to read the points, but again we can do some more practice here. It says that in order to plot a point on the Cartesian plane, right, in order for you to plot a point on the Cartesian plane, the x-ordinate must be determined first, all right, followed by the y-ordinate must be determined second. All right, the same principle as I had mentioned before is applied when you're reading or indicating the coordinate values from the grid. So you would state the coordinate values of the point in that exact order. You would state it in a x and y order, like x comma y. Always like that you will name your points. Let's have some practice here. Let's look at this point right here. This is the red dot here. So you can see that the scale basically, as I mentioned to you before, has changed depending on the objective of the question. So we are now using what is known as a 1 to 2 unit scale here. So it's 1 unit, 1 block to represent 2 units. All right. So right in between here would be 1. All right, in the event. So here we're going to go across 2 units and we're going to go up 4. So this point value here would have been 2 comma 4. All right, here we are going to look at the value over here. This another red dot here. So here we can see that we take 2, 4, 6, 8, so that's negative 8 units to our left, and we actually took 2 steps up, reading from the scale here. So we take 2 steps up. Remember that the scale, guys, is not the same as a 1-to-1, so that's why as we go up a unit, it's representing 2, because it's a 1-to-2 scale. All right, down here you can see that we have traveled 4 units to our left and we have traveled 4 units down. So this basically becomes -4 comma -4. That's that point. And here over here we have 8 units. You can see 2, 4, 6, 8 and 2 units down. So that's +8 and -2. So in the future, plotting a point, you will find yourself landing in one of those 4 spaces. Now, in addition to you landing in a space, then you can also find yourself landing exactly on the axis. So for example here, this point here, you can see that we didn't have to go to the left or we didn't have to go to the right. We didn't have to move. So basically this point here is saying that I traveled 0 units on my x-axis, but then I had to go up 2 units to get to my point here, so that's 0, 2. Down here, again, I didn't have to travel left or right to get to this point here. All I had to do was just travel 0 units to my left or right, and again I would have to travel, as you can see here, 4 units downwards. All right, over here a little bit vice versa to what we've been doing. Now I do not have to travel, well, I have to travel actually 2, 4, 6, 8. I'm already at my location. So here I would travel 8 units on my x-axis, but notice that I'm already at my point, so I don't need to go up, nor do I need to go down. So that's going to be 8, 0. And over here, naturally, you're going to find that, hey, I'm going to travel 4 units to my left, so that's -4 to my left. And notice that I'm at my point already, so I don't need to travel up or down, so that is 0. All right, and that is basically the 8 positions in which, not 8 specific positions, but 8 places along the Cartesian system which you can find yourself landing on a point. All right, so just be aware, right, of how to plot your points. Very, very important, right? When we reach further into the concept, you're going to definitely want to have this part down, because there's more videos, more topics we're gonna have to plot points a lot. This is a very, very important concept for you to grasp. All right, so now that we have that laid down now and we're all comfortable with how to plot a point, leave a like, leave a comment if you have any suggestions down below, and let's move right along. All right, so we're 21 minutes into our video here. Let's continue now and move on to some more important concepts in coordinate geometry. All right, now the location of a point will fall into one of the positions, or it can fall exactly on an axis that was mentioned prior. All right, so as you can see here, those open spaces where you see me plotting the points here and here and here and here, you can see that they are labeled as quadrants. All right, those open spaces with the points are called quadrants, and you can see here that when we're labeling the quadrant, we label the quadrant in a counterclockwise direction. So this quadrant up here, which is the positive quadrant, all right, that quadrant there is called quadrant 1. All right, and then we take an counterclockwise direction, counterclockwise, to label the remaining quadrants. So over here would have been quadrant 2, down here would have been quadrant 3, which is basically my negative quadrant, and of course over here finally is called quadrant 4. Quadrant 2 and quadrant 4 is a mixture of of negative and positive ordinates. All right, with here being the negative x ordinate and down here being the negative y ordinate. All right, now we're going to basically go on the graph and we're going to plot these points, but before we do so, we're going to predict in which quadrant would the point actually fall. Now I want you to pause the video here and of course leave a comment down below just before watching the video. All right, and let's just be honest here, which quadrant would each of these 6 points fall? Do not plot it, just look at the point and make a guesstimate. All right, so you would have made your guesstimate already, and that's good. If you've gotten all 6 correct, thumbs up, you are in fact grasping the concept. Now, when we look at here, -2, 5, you can see that the -2 is an x ordinate, and the 5 is a positive ordinate. So here we would find -2 over this side, and we'd find +5 up here. So if we were to go ahead and plot the point, all right, so that's here, -1, -2, and up 5, 1, 2, 3, 4, 5. Then you're going to find here naturally that it falls into quadrant 2. All right, quadrant 2. Very good. Here, 3, -7. You're going to find over here being 3. That's +3. That's 1, 2, 3, and down 7. That's 1, 2, 3, 4, 5, 6, 7. So right here, location, you're gonna find that that point here lands in the 4th quadrant. Okay. Next one here, -1, -4. So that's -1 to this direction here, and 4 up here. 4 up here. Oh, pardon me. It's -1 here and negative 4 down here. All right, mistakes can be made, guys, but let's just catch on to ourselves. That falls in here, our third quadrant. And here 6 2, that is 6 2, you're right, that is here, and 2 up, that's 1 2. This is falling in quadrant number 1. All right, now for the other 2 additional points, will it fall in a quadrant or will it fall on a line? Well, once you see a 0 involved in one of your coordinate values, then more than likely, if a 0 is involved, it's going to be falling on an axis. Let's see what axis this falls on. 0 on my x, so that means I do not have to go left or right. I do not have to go left or right, but I have to go 2 steps up. So I fall here on the positive y-axis. And negative 4 0, that is negative 4 in this direction here, that's negative 4 here. And again, you can see I don't have to go up or down because my y value is 0. So here I'll fall it on the negative x-axis. All right, so hopefully you guys really got a hang so far of how to plot a point, how to read a point from the Cartesian plane. All right, so we're gonna get right into it. All right, let's continue with our lesson. Now we're gonna move on now to, we're getting closer and closer now, guys, into the really important aspect of coordinate geometry. But before we actually get into the calculation aspect, we have one more concept that we need to fathom, and that is how to actually draw a line. All right, now we did mention earlier by definition that a line is a series of points that are connected in a straight path. Again, we are reiterating, a line is drawn simply by connecting any 2 points on the grid. But essentially, the most 2 important points that you need to draw a line, especially when it comes to the Cartesian or the coordinate system or the Cartesian plane, there's only 2 specific points that's important, and that is the point at which it crosses the x-axis, and of course the point at which it crosses the y-axis. Once you're able to determine those 2 points, then you're going to find it very easy to draw a line. Now this concept is very important for you to grasp, because in a later tutorial, which is known as linear programming, you're going to find that this concept here of finding the x and y intercept will play an important role later on. So do stay tuned for that. Ensure that you are subscribed to the channel. Now, a line usually is named by a single letter. All right, a single letter, or most times you're going to find that we give the starting point of the line named with one capital letter, and we also give the ending point of the line named with another capital letter. So you may see we refer to line AB or line PQ or line XT or line WY or variations of that sort. So you are going to be naming a line most often than not with capital letters at the beginning and the end of the line. Okay, now once we have that concept down now, right, we can basically move on to what is known as the slope. The slope, or most commonly referred to as the gradient of the line. And so what is the gradient? The gradient / the slope, right? There are basically 4 ways in which a line can slope. All right, a slope can be negative. All right, and this is where you're basically going down a hill. All right, I'm going to pull up a document for you in a moment for you to see. So for me, the easiest way to remember what a negative slope is me imagining myself going down a hill. And of course, a positive slope here is where I'm imagining myself going up a hill. All right, now we have what is known as an undefined slope. It has a magnanimous gradient, a gradient that is immeasurable. And we also have a line here where the gradient here is 0, or pretty much there is no slope, 0 gradient, neutral slope. All right, now what is a slope? What's the definition of a slope? A slope is the measure of the steepness of the line, and its level of steepness occurs as a result of a change in the y variable compared or with respect to the change in the x variable. We're going to elaborate more on that in a moment, but for the most part, I just want you guys to take a picture, mental picture of what the lines looks like when they are sloping. We have a negative slope here, a positive slope here, an undefined slope here, and a slope with a value of 0. All right, so here basically we're looking at the fact that the gradient formula, and this is a graphical formula, guys, it is a change in y. All right, so it's the difference between the y values, all right, and a change in the difference between the x values of the line. And here's a nice demonstration here for you. X-axis, y-axis, here's my line here, and the distance between the tip of the line and the base here is a change in y, all right, with respect to a change in x, all right, and that is how we measure our gradient. So basically, let's say that we end up with a gradient of, say, for example, 2/3. What this really means is that for every 2 units you move the line up along the y-axis, there's going to be a change in 3 units on the x-axis. That's basically what it means, but we're going to get into that in a moment, guys. Everything will become clear. All right, and again, as I mentioned to you before, this is the document I was talking about to visualize or predict what type of slope, not what the slope is now, guys. To determine what type of slope a line has, we will simply have to visualize ourselves going up or down a hill. And so, as you can see here, going from left to right, the cyclist has to push a positive slope. All right, so from left here, as you can see, from left towards the right, he has to push a positive slope. And of course, as you can see here, from right to left, he has to go from going down a hill, and here is a 0 slope. All right, now there are 2 methods in which we can calculate the gradient of a line. And so therefore we have what is known as the graphical method, which is going to be very, very important, guys. And of course, from the graphical method, we can derive a theoretical formula to find the gradient of a line. All right, now we are half an hour into our tutorial here. It's free for you to go ahead and pause the video, take a little break, take a drink break. That was a lot of knowledge there for you, and you can return and come back. We're gonna get right into the more technical applications of coordinate geometry. All right, let's go. All right, guys, so here for the graphical method now, all right, in order for us to apply the graphical method or technique towards calculating the gradient or the steepness of a line, we have to do what is known as creating a right triangle that subtends the line. All right, so we simply create a right triangle with any 2 points on the line, and it doesn't have to be the start and the end, it could be anywhere in the middle. Once you create a right angle triangle connecting those 2 points, then basically what you have done is that you have created what is known as the rise and the fall. All right, the rise or fall as well as the run. Now, why we say rise or fall is because a lot of times the ambiguity of using the word rise implies to student that is always something that goes up, but we have what is known as a negative rise, which we refer to as the fall. All right, so once you've created the right angle triangle, the vertical distance of the right angle triangle will create what is known as the rise or fall, and the horizontal aspect of the right triangle will create the run. All right, now it says here that since the gradient is a change in y with respect to x, then we simply then a simple way of finding the gradient is to divide the distance of the rise or fall by the distance of the run. All right, please note that the gradient of a line is indicated by a common letter which we use as m. All right, so look out for this m in the future. You're going to see it a lot. M is the symbol that represents a gradient. All right, so basically that's the formula that we're looking at here. See, here I have a line. Here's my y-axis. and here's my x-axis, and I just have a random line here that is going across x. We're not seeing the bottom half, but yes, it's going to cross the y-axis. But here I have a line, and what I've done here is that I've selected 2 points. One is here and one is basically here, and what I've done is that I've created a right triangle that subtends the 2 points, all right, that connects the 2 points. And so this distance here is known as my rise or fall, and this distance here is my run. So if you were to calculate this using a, say for example, a 1-to-1 scale, then my rise distance here would have been, let's say here, 1 unit, 2 unit, 3 unit, and I'm actually going in a downwards direction. So for this particular line here, my rise, or in this case my fall, is going to be -3, and now I'm running towards this direction. I'm only running 1 unit, so that's 1. So for this particular line here, the slope here is going to be -3 for this particular, and pardon me, this is actually -1 because I'm going in the left direction. So my slope of this line here is a +3. Now, very important, guys, I'm not sure if I've mentioned how important it is. Direction of your values are going to be important. So if you're going down, it's negative. If you're going to the left, it's negative. If you're going up, it's positive. If you're going to the right, it's positive. So be careful of your signs, because you may or may not get the slope / steepness of the line correct. So for this particular line, the slope is 3. Let's take a look at some more application questions here as it relates to this. So for this one here now, I have a straight line that passes through the points -2, 1, as you can see here, -2, 1, right? -2, up 1. And I also have another point somewhere on the line that is at the position 4. That's 1, 2, 3, 4, 1, 2, 3, 4, 5, 4, -5. Now, for me to demonstrate and for us to do this successfully, all we have to do here is just to create a right triangle that pretty much subtends the line, or subtends the point. And there's my right triangle. Now I have a choice to do it on the bottom half, or I could do it on the top half. So here I'm going to change my ink, and I'm going to just do it on the top half here. Here's my rise. I'm going to rise from this direction, right? And I'm going to run in this direction. You're going to see that no matter which direction you take it from, right, you're going to always get the same answer. So let's have a look at the formula here. We know that the gradient m is equal to rise / fall over run. So this time now, we're going to see if we're rising or are we falling. From this side here, we are falling. How much are we falling? What's the unit of the fall? 1, 2, 3, 4, 5, 6. So m is equal to a fall of 6. And the run here, I'm going to run towards my point. So I'm running to my right. All right, so I'm falling. So that's -6. And I'm running to my right. So that's 1, 2, 3, 4, 5, 6. So I'm running +6. So when I divide -6 by 6, I find that the slope of this line here is equal to -1. All right, if we were to go on the other side now, all right, just in case you guys may be questioning, is it a case where I have to go on the left side or the right side? It doesn't matter as long as you have a right triangle. So once again here, my rise / fall divided by my run. Okay, so my m here is equal to, let's see if I'm rising or falling. Here I'm rising, so I'm rising 6. 1, 2, 3, 4, 5, 6. So that's +6. But this time, as you can see, I'm running to my left. So because I'm running to my left, here you're going to find that it's negative. So that's 1, 2, 3, 4, 5, 6. So that's -6. And again, you can see that we reduced our answer once again to being equal to -1. So as it relates to the direction in which you choose to draw your right triangle, it doesn't matter. Now, if you happen to be on a Cartesian plane where you have more than one lines, try to construct your diagram in a direction that's not going to interrupt with the line, all right? But it doesn't matter which side the right angle triangle is on. So hopefully you guys got some clarity on that demonstration there. All right, now I do have some examples. I will leave a link in the description to a page on Google where you can find practice questions on the questions as it relates to finding the gradient using the graphical method. All right, so here we go now, guys. In addition to the graphical method, now that's pretty easy. I know that you guys have that locked down. Now, in addition to the graphical method, we can actually use coordinate variables to derive a formula. Now, we did say earlier that the gradient / the slope of the line is a change in y with respect to a change in x. Now, the word change implies subtraction, the difference. A change means the difference between two single ordinate values or coordinates or points. All right, so here we have derived a formula. Now, typically when you get a line to be drawn, you're going to be provided with two pairs of points. All right, and so the pair of point is going to be in the form x1, y1. All right, see, I've labeled it here in two different colors. Once you get a line to draw, you're going to be provided with a point, and we're going to call the first point, or the starting point, so to speak, as the x1 and y1 values. I typically tell my students that the x1 and y1 is the starting point, but that is not necessarily perhaps say true. We can look at what, let's say that you're in a class and someone sits beside you and they decided to call the point to which you are calling the starting point. What if they wanted to call it the ending point? That is also fine. You can choose, but typically you're going to find that the starting point of the line is x1, y1, and the ending point is x2, y2. Now, since there is going to be a change in the y value with respect to the x value, then you can see here that we have y2 and we're finding the difference between the y ordinate values of the point. So that's y2 take away y1. So that's the change. That's this subtraction here is going to tell me the unit distance between the y ordinate values. All right, and then that's a change. All right, that's going to calculate the unit value of the rise / fall divided by the run here, which is a difference between the x ordinate values. That is x2 take away x1, and that is our standardized gradient formula, the formula theoretically that we can apply later on when we are not on graph. All right, so over here you can see now how we construct the formula. It is the difference between the y ordinate, that is y2 take away y1, divided by x2 take away x1, and that is how we pretty much construct this formula. But this is not a very difficult formula to remember. Try to get it up here in the head, guys. It's very easy. It's not a formula provided to you by CSEC, right? It's a formula that must be mentally in your head, so you have to work on getting that up there, guys. All right, so it's y2 take away y1 over x2 take away x1. Let's look at some structured examples, guys, as it relates to this. Now, I am assuming, based on the time that we have left and how many practice questions I have, this is going to be the last set of explanations in this particular video. So if you want to see part 2 of this tutorial, ensure that you are subscribed to the channel. Your post notification bell is on. And if you've gotten some sort of value, from this tutorial here, leave me a like, and of course leave your video requests, suggestions down into the comment section box below. All right, so here we go. We have here a question that says, given that the point A 2, 5 and of course the point B 5, 1, right, determine the gradient of the line that connects the point A with the point B. Now, we're not on graph, so there's no point in us actually drawing up a Cartesian plane, plotting the point A, plotting the point B, doing your rise, doing the run. There's actually a formula that we can actually write down, and that's what we had determined earlier, that the M gradient is equal to y2 minus y1 divided by x2 minus x1. Now, before I forget, I strongly recommend that I find that quite a bit of my students in the past, they like to actually look at the numbers and transfer it down here. I strongly recommend that you practice, get into the habit of actually labeling your points before you start your substitution. So I strongly encourage students to say this is x1, y1, and you're going to find that in all of my tutorial, no matter how good it is that I may be at working the problems, I always tend to label my points. All right, that's how I normally go about doing it. And then from there now, guys, all I do is that I take my time and I look at my label and I transfer the points down here. Now, you gotta also understand that sometimes you're gonna end up with signs clashing, so it's very, very important that you practice to do this. And not only do you practice to write down your formula, when you're writing down the formula for every question that you practice, the formula is slowly but surely being processed by your permanent memory. It's going to go in and it's never going to come out. But if you try to do it without using the formula, then you're going to find yourself getting a bit tied up most of the time. All right, so we're just going to carefully plot our points, substitute our values, our ordinate values into our equation. All right, so here we have y2, which we can see here is 1. Take away y1 here, which is 5, and divided by x2 value, which is 5. Take away x1 value, which is 2. And when we work this out here, you're going to find that 1 take 5 is negative 4, and 5 take 2 is 3. So the slope, or the slope value of our line here, is minus 4/3. Now, in the event that you wish to turn it into a decimal, that's going to be minus 1.33 recurring. Okay, but we typically don't use decimal places when it comes to coordinate geometry. So hopefully you guys got a hang of that. Let's move on to some more practice questions here. A straight line passes through the points minus 2, 7 and 3, negative 4. Our task is to determine the gradient of this line. So once again, gradient formula is m equal y2 minus y1 over x2 minus x1. So here we have m. Let's label our points: x1, y1, x2, y2. So y2 label is negative 4, and we're subtracting the y1 value, which is 7, so we're subtracting 7, and the x2 value here is 3, and here's where we're gonna have to be a little careful now. So the x2 value is 3, and now watch what we're doing here is that we're subtracting a negative number, so we're subtracting negative 2. And this is what I was talking about earlier about the sign clash here. Once you miss that sign clash, or you tend to write down an incorrect value, there goes the incorrect value for your gradient. So just be a little careful with that. Negative 4 minus 7, that's minus 11. And negative clashes with a negative, becomes a positive. So we end up with 3. Instead of take away 2, we're going to add 2. So we end up with 5. And so that is the slope value of our line, negative 11 over 5. All right, pretty good, pretty easy. You guys got this. Let's move on to another example. Now, I had mentioned to you before in our first example that the importance of actually writing down your formula, because remember that the gradient formula is an equation. So you're not necessarily going to always be asked to calculate the gradient depending on the level of math you're doing. At the CSEC level, I've seen where questions come across where you're not necessarily asked to calculate the gradient, but you're asked to calculate an ordinate value that is in one of your points. Now in this example here, you can see that we are told what the gradient is. We are told that, hey, given that the gradient of a line is equal to 5. So here we are told that the gradient is in fact 5. So we know what m is. We already know that m is equal to 5. Alright, now it says here in reverse that we are to determine the value of the x-ordinate given that it passes through the point 5 minus 3, and in fact, hey, this ordinate value is missing. So how are we going to solve a question like this where we don't have the actual ordinate value? Well, we have to practice to write down our equation and do proper substitution. So we're going to start off by writing down our formula, that is m is equal to y2 minus y1 over x2 minus x1. Now the gradient here is 5. Alright, so we're going to have 5 is equal to, and before we proceed, let's go ahead and label our points. Now even though one of the ordinate values is missing, we're still going to label it as being what? Let's say here x1, y1, and this is x2. So basically x2 is missing and y2. So we're basically going to transpose the equation here to find the x2 ordinate value. So y2, you can see here, is 2. And we're going to take away y1, which is a negative 3. So that's 2 take away negative 3. And that's going to be divided by x2, which is the value that we're missing. So that's x. Take away x1, which is 5. Alright? So we're going to be solving an equation. And this is where your application, this is where algebra comes into play now. Right? We're going to have to learn how to solve equations. The video link is in the description box below. Check that video out if you're struggling with solving equations. I have a couple more equation videos coming out, so do look out for that, guys. But you have to ensure that you are subscribed to the channel to be notified. Okay, so here we go. Let's work out what we can. We have 5 is equal to, let's evaluate the top. Negative multiplied by negative is a positive. So 2 plus 3 is 5. And that's going to be divided by, clearly I cannot subtract 5 from x. Let's just write that a little bigger. So that's 5 over x minus 5. So how do we proceed in solving this particular equation? We can multiply both sides by x minus 5, or naturally what I find a lot of my students say is that they're going to cross multiply. So we're going to cross multiply here. Okay. So by cross multiplying here, we're going to find that 5 should multiply x, so that's 5x, and 5 is going to multiply negative 5, so we end up with negative 25. And that's going to be equal to 1 multiplied by 5, and that's equal to 5. That is how we cross multiply. Now, of course, I did a video on how to solve basic equations like this. So here, transposing negative 25, we end up with 5x being equal to 5 plus 25. So we end up with 5x being equal to, hey, 30. So if we divide both sides by 5, then you're going to find that the x ordinate value here works out to be 6. All right, really nice improvised question here using the gradient formula. It comes up a lot. All right, you cannot really put anything past CSEC. You have to be prepared for all variations of question, and this is just one of many that is coming up in this particular tutorial. Let's do an example now where we are actually finding a y ordinate value. So here we have just made it a little bit more challenging by making the gradient a fraction. So we're going to add a little bit of complexity to the problem now. So here again, given that the gradient of the line is equal to 3/4, so there we have our m is actually equal to 3/4. All right, 3/4. All right, so now we are to determine the value of the y ordinate value now, given that it passes through the points 2, y, and 4, negative 1. What is the value that is supposed to go here that will cause the gradient of this line to be equal to 3/4? We start off naturally by saying, hey, m is equal to y2 minus y1 over x2 minus x1. We set this up, guys. All right, so we're going to go right ahead and do some substitution. M, we know, is 3/4, so that's 3/4. All right, write it properly, guys. All right, write it as a fraction like so. So let's label our points as usual. All right, this is x1, y1, and this is x2, y2. So clearly you can see it's the y1 value that is missing. So we are looking for y1. So here we go. y2 is negative 1. And we're going to take away y1 value, which we see is labeled as y, over x2, which is 4. And we're going to take away 2. We're going to take away 2 from that. So that's x1 value. Let's go up here. So now we have 3/4, and we can work out what is at the top. Well, in fact, we can't work out what is at the top. So that's just minus 1 minus y over, we can work out what is at the bottom. 4 take away 2 is 2. All right, remember that we cannot subtract unlike terms, so we can't do much to that. Now what we can do now though is that we end up with an equation, a fractional equation. We're gonna have to cross multiply. So here we go. We can start with any side. I'm going to start with the 4. All right, since as this is taking me in the direction of my subject. So 4 multiplied by negative 1. 4 multiplied by negative 1 is negative 4. And of course, remember that the 4 also has to multiply the negative y. So you end up with negative 4y. And that's going to be equal to, we cross multiply in this direction. 3 times 2 is 6. Now, naturally, we solve this equation here, transpose the negative 4. So we end up with negative 4y is equal to 6 plus 4. So we end up with negative 4y is equal to 10. All right, I'm running out of space here, guys. So let's see if we can drop it somewhere in the middle here. So negative 4y is equal to 10. In the middle here, negative 4y. So we can divide both sides by 4. So we're going to find here that y is equal to 10 divided by negative 4, which we works out to be, as a decimal, it would be negative 2.5. As a fraction, it would naturally be negative 5 over 2. All right, it would be negative 5 over 2. So both answers are acceptable. So the y-ordinate value here is negative 5 over 2. All right, so tough question. It really depends on how much you know about the concept or how much you know about the topic. All right, just let me know in the comment section, guys. And if you have any concerns, feel free to just replay the video and just kind of focus a little bit. Give it a try before you actually watch my solution. And when you've done, look at my solution and see if it matches with yours. All right, and basically now we're gonna wrap up this aspect of the tutorial video now by looking at drawing a line. So here is a different structured type of question now. Here we are being asked to go on the graph and we're going to actually draw the line that contains a slope of 3, negative 4, 2/3, and negative 3/5. What if you were given a question where you are to draw the line that contains a certain slope, but you weren't given the actual points? Now, what I like about this structured type of question is that I am free to draw the line anywhere on the Cartesian plane that I desire, right? Because anywhere on the Cartesian plane that the line is, it will still have the same exact gradient. Remember that the gradient of a line is not determined by the quadrant that the line is in, but it determines on the steepness of the line wherever the line is on the Cartesian plane. Now, in order for you to do an actual structured example, and I'm almost certain that in my regular classes, right, if you're watching this tutorial video, you can find all the information related to how to get in touch with me to join my regular live classes, right? You can check out that. But when I'm teaching my students, I don't think that I actually taught them a concept like this. But this is very, very important here, guys, that this question could come. So what you can do now, guys, is that you just choose a specific point of intersection on the Cartesian plane here for you to draw your line. Choose a specific location, it doesn't matter. So I'm just going to choose here. All right, I'm going to start my point here. All right, and I need a slope of 3. So it means that for me to have a slope of 3, it means that I have to be able to have a rise that will I would have to have a rise that can be divided by the run to give me 3. So let's say that I chose a number randomly. Let's say I chose 6. It would mean that I would have to go up 6 directions. So that's 1, 2, 3, 4, 5, 6. Whatever number you choose, whatever distance you choose to travel upwards, there has to be a number that if you divide that number by the x value, then you're going to get 3. So if I choose 6, I have to ask myself, what can I divide 6 by to get 3? So I choose 1, 2, 3, 4, 5, 6. If I basically divide 6 by 2, I'll get 3. So I'm just going to travel 2 units. So I could put a point here, and then basically here, you're going to find here that this is a line that replicates a slope of 3. So here, right? So here, that's my line, right? So you can see that my rise is 6 and my run is 2. So 6 divided by 2, 6 divided by 2 is 3. All right, and that line could be anywhere on the Cartesian plane. Just you have to choose a number that once it divides by another number, then you're going to get the result that you're looking for here, right? I could have chosen 12, and so if I divide 12 by 4, I would have gotten a gradient of 3. Second example here, I need a gradient of -4, so I know right away, let's say that I put a point here. All right, I need a number that when I divide it by another number, I'm going to get 4. So let's say that I choose 8. All right, I need 8. I need a negative gradient. So I need to go, hey, let's put it here instead. All right. Sometimes depending on the point of the location that you choose, you may end up have to relocate that point because you may not have enough distance on your graph to travel. So I need to have a negative rise, all right, or a negative run, all right, one of the two. So if I rise positively, I'm going to have to run negatively. Or if I rise negatively, I'm going to have to run positively. And if I rise positively, I'm going to have to run negatively. So you have to do the opposite. So here I need a number that I know can be divided by another number to give me 4. I'm just going to choose 8. So what I'm going to do is that I'm going to fall 8. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So here I'm going to fall 8. 1, 2, 3, 4, 5, 6, 7, 8. Fall 8. And then because I fall 8, that's already negative. I need to run 2. Because if I divide 8 by 2, I'm going to get 4. So I'm going to run 2 here. And that's my location here. All right. So if I go like so. Okay, this particular line here would have a slope. So you can see here that my rise is -8 and my run is 2. So 8 divided by 2, -8 divided by 2 is -4. Over here you can see that 6 divided by 3 is 2. All right, so there we go, guys. What I want you to do for me in the next tutorial, which is part 2, I'm going to pick up on this here as a recap for part 1 for you guys. So I'm going to do here 2/3 and 3/5, -3/5 in the next tutorial video. All right, so we are just about an hour over into this particular video. Do take care until next time. In part 2, we're going to talk more about the gradient, midpoint, length of a line, so on and so forth. All right, do not forget to smash the subscribe button below, turn on the post notification bell, leave me a like if you've gotten some value from the video, and of course leave your comments, video requests and suggestions down in the box below. Do take care. I'll see you next time. Bye bye.